So this is the very last lesson of Year 12 General Maths. So far, we've only dealt with matrices that have the same number of rows as columns, meaning what? That means that they're square in shape. Matrices don't always have to be square. Unfortunately, the Hungarian algorithm that you've been hammered with only works on square matrices. So what do? To fix this, we simply make the matrix square. How do we do that? You add a dummy row or a dummy column full of zeros. Then you apply the Hungarian algorithm. Please note, if you're maximizing, where you do the matrix inversion, you need to invert first, then add the dummy row of zeros or the dummy column of zeros. So once again, for the people that came in later, the last lesson of Year 12 General Mathematics is the idea of dealing with non-square matrices. Hungarian algorithm only works when they're square. So same number of rows as columns. So how do we fix this? You make it square. How do you make it square? You add the right number of rows or columns full of zeros to make it square. And just the added note of if you're maximizing, you need to invert first, then add the dummy row of zeros or the dummy column of zeros. Can you get that, please? And the example, I'll just zoom out slightly for the people that came in later. You'll need to get the notes, but other people, the example is we added a swimmer E to our team. How many strokes are there in the team? There's 4. How many team members are there now? There's 5. So the only difference when the matrix is not square is someone is not going to swim. So can you get those 2 dot points above the example down, please? Then the example, we'll do the work example together, and then that's it for your year of Year 12 General Maths. So you might remember that lesson where you had Hungarian algorithm for the first time when I said, this is all you're doing until the end of the year. That is a true sentence. You guys have a question? He started already. So you guys that come in later, today's lesson is titled Non-Square Matrices. Why do we need this? Because Hungarian algorithm only works when the matrix is square. So how do we deal with that? We make it square by adding rows or columns of zeros. Then we do Hungarian algorithm as normal. Get the example down, please. We'll do it together. You're doing 12B.4, and that's it. Put that line through or highlight that portion of your timeline and feel good that it's finished. You'll be doing test revision until next Thursday. And exam revision for the rest.
So what was it called?
Non-square matrices. Looking at that example, what do I have too many of? Do I have too many rows or do I have too many columns? I've got too many rows, so what do I need to add full of zeros? A column of zeros, 1. Can you not? You can get up here, you can talk into this as well. 3, 4, 5. Now it's square. Now it's 5 by 5. That's your first step. Double check. Do we want the fastest team? Yep. So I don't need to do a reversal. I don't need to invert it. So now I can start. You tell me. With Hungarian algorithm, what do I do first? Rows first or columns first? Rows. And what am I doing with the rows? Subtracting what? Subtracting the smallest. What do you notice there? Is the smallest always 0? So don't waste time. Step 1 is done because I would be taking 0 from every row. So I can skip down to the columns one straight away. What's the smallest number in the first column? 55. Smallest number in the second column?
58.
Smallest number in the third column?
52.
Last.
49. No, 48.
And then 0. So we subtract the smallest from each. So you're going to be taking 55, take 58, take 52, take 48, take nothing. So redraw the matrix. 56, take 55.
1.
62, take 55.
7.
Next.
0.
Next.
3.
Next.
6.
Breaststroke. 59, take 58.
1.
Next.
9. 6. 2.
Look at you.
0.
Wow. I'm not even that fast at subtraction.
Yeah.
Is this like your special gift? Are you an X-Man?
My only gift.
Next. Let's do it. Let's see if he stumbles.
0.
I still need that assignment there. Next.
6.
Next.
2. 1.
Come on, quicker.
5.
5. 1. 3. 0. 2.
All zeros. What do we do now? Noughts and crosses. What's the biggest number of zeros I can hit in one go? 5. What's the next largest number of zeros I can hit in one go? Are there multiple ways to do that? Doesn't matter the order. I'm going to go horizontal because I like it. 2. How many lines did I just draw? 5. How many rows are in the matrix? No, look at it. 5 lines drawn. So now I choose the most alone zeros. This 0 here, alone in its row. Alone in its column.
Yes.
Yes, circle it. Alone in its row, alone in its column. It's got held of friends, so just leave it alone. Next one here, alone in its row. Selected. Alone in its row. Alone in its column.
Yeah.
Alone in its row, alone in its column. Leave it alone. Next one. Alone in its row. Alone in its column.
Yes.
Last one is process of elimination. What's the only column that hasn't been selected? That one there. So what does that translate to in the context of the question? Swimmer A does... So please, every year someone stuffs this up because they forget that this has an extra column now and they read it off and they miss. So this 0 here is here. Okay, if you want to double check, place that pattern on the OG so you don't stuff it up and try and do everything in your head. So A is going to be doing butterfly now. B is going to do, he's too slow, so he does nothing. Not selected. C does backstroke. D does freestyle. And E has taken over B. E's doing breaststroke. That's how you handle non-square matrices, people. You add a row or a column of zeros, you do the same bloody thing over again. That's 12, is it 12D or 12B.4? Whatever the